welcome from the central coast of California in San Luis Obispo, where it's a beautiful day and about mid-70s. And we are looking forward to presenting this topic on tilt-up construction, and it's going to be focusing primarily on seismic design, specifically in higher seismic areas where this type of construction can be a bit problematic. But there'll also be plenty of information about slender wall design that you can apply to wind design and other parts of the nation. But there will be a fair amount for lateral and seismic design in this presentation. Also, because out here on the West Coast we have a fair amount of this inventory with wood roof systems, there will be some of that presented. But again, a lot of the discussion can be applied to metal deck as well as wood roof systems. I hope to present you a good history of where we have come to the present day, as well as some future provisions. So whether you are just starting an engineered tilt-up construction in your office, or you're a very seasoned veteran doing tilt-up construction, I'm pretty sure you're going to hear something interesting and new no matter where you are along that spectrum. So if we take a look at where we are with tilt-up construction and how I'm going to present this today, the different topics I'm going to bring up are the slender wall design, as it is in ACI, wall anchorage provisions, primarily that are in ASCE 7, diaphragm forces that need to be designed in the roof diaphragm that can come from ASCE 7, as well as how they're dealt with in the different material standards. And then the shear wall issues that you might see in these buildings from ACI standpoint, whether it's a shear wall or a wall pier or a frame element. I'll give you a little bit of guidance there. And then at the very end, as I mentioned, we'll be talking about future possibilities of where the code may change directions so that you have a sense of maybe what's happening behind the scenes right now. Our learning objectives for today's course, well, the first one is to really understand the background and current implementation of the slender wall provisions and evaluate the shear wall anchorage forces and their transfer into the diaphragm is a second learning objective. Classifying these shear walls for design as whether they're shear walls or frame elements or something in between. Giving you a familiarity with the 2012 or the 2015 IVC provisions. There's really not that much that has changed between those two code editions. And a glimpse into the future design direction. So in summary, we're looking at the slender wall provisions, wall anchorage forces into the diaphragm, as well as classifying shear walls, our current building code provisions, and the future. So it's a little bit of everything from beginning to end that you'll be exposed to today. Slender wall design. Well, the slender wall design really began back in the 50s and 60s and has evolved up to current day. And what makes it very unique that was recognized very early on are these wall panels are very, very slender and subject to a fair amount of deformation out of plane. And so the slender wall provision requirements recognize that P delta requirements are very important, that you have to take into account the second order effects of the deflected shape. Also, eccentricities are very important. Because it's so thin, a slight eccentric gravity load can cause a fair amount of moment in these and added deflections. So thus there's some very special limitations. For instance, they have to be tension controlled. We don't want to have any compression controlled members in these. They need to be very ductile and flexurally controlled members so that they would have a fair amount of deformation possible before they would begin to fail. The axial stress is limited for these, so they're not really heavy bearing walls necessarily, but carrying light roof structures typically. And the deflection is going to be very critical from a service level standpoint. So we'll be looking at these as we go. So let's take a look at these different issues for slender wall design in the perspective of the historical development. We'll be looking at some past changes to ACI and why they happened. And also we'll give you an example of the slender wall design to use. And then we'll have our break at the end of that, our first break, where we can answer some questions that you might have at that point. So let's take a look at the historical development, because this is pretty interesting, especially if you're trying to understand where these equations came from and some of the differences that have been between the ACI 318 code editions through time. First of all, The tilt-up process of these buildings has been around since, I believe, the early 1900s is when the first tilt-up building was built. But it really didn't start taking off, at least on the West Coast, where the mature market really started building fast in the 1960s, actually in the 1950s and 60s. It really took off in the 70s, and it's been strong really pretty much ever since.